Let's discuss this question. Using elementary transformations, find the inverse. So, in this question, what kind of a transformation would you like to use over here? Now, we have been using alternate row and column transformations. It's time to take this question using row transformations. Let's use row transformations for this question. Let us call this matrix A, okay, and what we'll be using is row transformation. For row transformation, what we require is that I should be written as a pre-multiplier. A is equal to I times A, right? This is a row by column transformation, row by column. So I has to be written as a pre-multiplier on the right hand side. What you have over here is a 3, 1, 5, 2, this matrix. I matrix is 1, 0, 0, 1, and this is matrix A, right? This is matrix A for us. What else? After this, we'll try to convert this, transform this into an identity matrix by transforming this one. After that, since we are using row transformation, let's focus on the first column, right? So let's replace R1 by 1 by 3 R1, and what we get over here is a 1. This is 1 by 3. This is 5. This is 2. They remain as it is. This is 1 by 3. This is 0. This is 0, 1, and this is A. Right? That's what you get. So first element, the element present at location 1, 1, that is A11, has been converted to 1. Next. Since we are applying row transformations, the first column has to be dealt with. This 5 has to be converted to a 0. So R2 can be replaced by R2, this minus 5 times this. Right? Simply multiply it with 5 and subtract. And what will that give us? The first row remains as it is, 1 by 3. The second row, this element becomes 0. 2 minus 5 by 3. 2 minus 5 by 3 is 6 minus 5. That is 1 by 3 over here. This is what I get. Okay. What next? This becomes equal to 1 by 3, 0. They will remain as it is. 0 minus 5 by 3, which will become minus 5 by 3. Okay. 1 minus 5 times 0 is 1 only. And this is matrix A for us. What next? Once you have this 1, this 0, let's convert this into a 1, or we can also subtract this, right? So let's replace R1 by R1 minus R2, and R1 minus R2 will give us 1, 0. This becomes a 0. This is a 1 by 3, which is equal to this minus this. 1 by 3 minus or minus 5 by 3 will become plus 5 by 3. 1 by 3 plus 5 by 3 is 6 by 3, which is 2. 0 minus 1 would become minus 1. Minus 5 by 3 remain as it is. This is 1. This is A. And now you can convert this into a 1. Replace R2 by 3 times R2, and which gives me R1 becomes 1, 0, 0, 1, which is equal to this matrix over here. 2 minus 1 remain as it is. Multiplied with 3, you get a minus 5. You get a 3 over here and times A. As you may clearly observe, this here is the inverse of that given matrix over there. Therefore, A inverse is equal to 2 minus 1 minus 5, 3. That is my answer for this question. But one very important thing, when you are given to find inverse using elementary transformation, always verify your answer. So let's check. A inverse. Now what is matrix A equal to? Matrix A is this 3, 1, 5, 2. What is the A inverse that we have just found? We have found 2 minus 1 minus 5, 3. Okay. Let's multiply them together and see what we get. This is 3 times 2, 6 minus 5 is 1, 3 minus 3 and plus 3, which becomes a 0. 10 minus 10 becomes a 0, minus 5 plus 6 becomes a 1. And yes, this is the identity matrix. That implies that the inverse that we have obtained is correct. That's all. Yeah, that is all in this complete question over here.